So, the last talk in this room for today and for the conference. Ooh, very sad. In this one, aha, there you go. All right, so we had a lot of numbers today. I love numbers, actually. And the next talk will also be about numbers, about data in general, and about a cool tool, I heard. And Søren is going to present it to us, and I'm pretty curious about it. So give a warm hand for Søren.
Yeah, hello and welcome to my talk, which is called Data Alchemy, Turning Your Data into Gold. Before we start into it, there's a little disclaimer in front of the talk. First, I'd like to speak about expectations. What to expect in this talk and what not to expect. You can expect to see or hear about useful tools for working with data. I will give you some very easy code examples, and I will show you some real-world applications we are working with in this kind of setup I will show you. You will not see or get a statistics lesson. There are no cat pictures in it, and you won't have lots of bullet lists. Yeah, that's the only two. Additionally, I will put this presentation on SlideShare, so there's no need to take hundreds of photographs. You can download it right from SlideShare. And according all the references and credits, there will be a references section in the presentation on SlideShare, so everything and not the fly will be found there, so you will find all the references to graphs, information, and so on. So let's start with me and myself. I'm CEO at DKD in Frankfurt, Germany. My favorite day in the office is Thursday, because then it's pizza day, and we're doing our favorite in-office pizza creation with our team. When I'm not in the office, I love to travel the world. When I have the time and see nice things, I love to take pictures of them. When the weather's right, I like to climb some rocks. And if the weather's not right, I like to develop board games. This one is a card from the next game, which will come out in January or February, which is called Half Pint Hero, and it's about a pub brawl. So when you want to take part in this, just let me know and I will inform you when it's there. But now, where's the data? Close your eyes for a moment and think about where in your company or in your home you have data lying around and which might have some value to you, but you don't use at the moment because you don't access it, or it's in a format that you can't use to a certain degree. And I've brought some examples. So, of course, there's accounting information. There's time records of your employees or your own work, or there's estimations you do for your clients or for your company itself. There's product specifications with all kinds of information. And maybe there's the company's Geiger counter, which detects the radiation level in your office. And you have all these kinds of data lying around, and there might also be some tools you already use, because I assume that you already work with data every day and do something. And the first tool that comes to mind is, of course, Excel. And don't get me wrong, Excel is not a bad tool. It's a really good tool, but it has its limitations, of course. And one of the limitations, which is, and doesn't sound so limiting, like only having 1 million rows in a table, but when you access real amounts of data, this can be a limit which you reach really fast. But that's not the only one. If you go to Google and look up the limitations of Excel, you find a page by Microsoft which states nearly 90 limitations that Excel has. So, do I want to work with it all the time? No, I don't. I don't want to worry about this. And there's this one thing which sometimes happens, and this is a real error message from Excel. So that's not so much fun, especially if you don't know what's it about. This takes me to the question, what can I do? Is there an alternative? And yes, there is. And one alternative we use, and I really like, and that's the most thing in this talk about, is called R. And R is not a pirate thing. R is something, if you put it into Google, maybe the shortest Google query you ever did, you will get to a site which is called, and it's the first hit in the Google search when you search just for R, projectr.org. And you find a web page which mostly looks like a university page, something not very attractive, and then you start reading in it and it says R is a language and environment for statistical computing and graphics. Wow, very appealing. I must download it right now. But I did, and then I got this small application. I dropped into the application folder, double-clicked it, and it started up, and wow, was that beautiful. When you then remove the welcome message, you're left with this. And yeah, let's go. What can I do with R? Yeah, of course, there's arithmetics. And if you press enter, then you get the answer, which is obviously 42. And yeah, I admit this is not really interesting. So, but there's more in R. Fun starts with vectors, what I always say. If you write something like this, this means I define something which is called x, and I put in it 1, 2, and 3. This is called a vector in R, and I do that again with y, and put in 10, 20, and 30. And if I now do arithmetic and write x plus y, then I did something really cool. I added all of them up in one line. No loops involved, no control structures. Everything works with this simple statement. At the first, it doesn't look like something very special, but this is the whole concept of R, that every operation you do always works on the complete data set. And this is really powerful, since if you do something in R and you write a loop, then you're doing something very inefficiently. So, to have another example, if you write something like sum of x, of course you will get 6 as an answer, because you can work on vectors itself as well. But this is not much of a data, so let's work with a bit more data. In this example, I just took a table of from the periodic table of elements and put in the name of an element, a symbol, number of protons, the weight, and the density in kilograms per cubic meter. So now I want to know which is the element with the maximum density, which is pretty straightforward. I enter it, press enter, and I get the answer of 19,300 kilograms per cubic meter. As I don't own a cubic meter of gold, sadly, I thought it would be cool to at least calculate the value for gram per cubic centimeter, which is easily calculated by just dividing the density by 1,000. So I can write it like this. I write something like density number 2, and the small arrow says put it in this variable, divided by 1,000, and then I have this new column in my complete table, and this table can be millions of rows long, and I get this value, which now tells me that my small cubic thingy will be about 19 grams of weight. So back to the company's Geiger counter I already mentioned. Why did I mention it? At DKD we have a company Geiger counter which was inspired by the company called Libellium. In the 2011 Fukushima accident, they produced an Arduino shield, which you see here, which is a very simple and cheap Geiger counter, which you can use to build a Geiger counter yourself very easily. And they spent gave as presents many of those units to the Fukushima people to be able to do measurements right at their homes. And whenever you buy such a unit, you support this project to helping people in countries or situations which need Geiger counters. But what does it do? It simply counts the pulses in the Geiger tube, and if you want to know more about what is this, radiation Geiger tubes and so on, just speak to me in the evening with a beer or so, and I will explain you a bit more detail about this. But it counts pulses and then calculates the counts per minute, which is kind of measurement of how many radiation is there. Then it also calculates the radiation dose, which is measured in microsievert in this case. And then it logs this value every 10 seconds, so we get about 8,600 readings per day. So taking several of our records from our Geiger counter, I get a very long table, and for this example I just took records from about 1.5 hours, and I can now use a command which is called tail, and if you use the bash shell, you already know it, what it does. And I now see, okay, great, these are the measurements for our Geiger counter. And when I now want to know which is the maximum value, or the average value in this case, I get an average value of 30 counts per minute for my 1.5 hour sample of the data. But what I'm interested in is, was there a certain amount of time which was particularly dangerous or something? So I can do something like with an SQL database and do something which is called a subset, and select just the records from our table which have a CPM of 60 or greater, and I then get this set of data and can use it like it was its own variable, or do whatever I want in R with it, because every operation creates something which can be used as its own object. So enough with this number stuff and so on. Doing all this stuff is quite theoretical at this stage. Of course, you can use the data and make it more beautiful, like creating graphs and diagrams. Putting such a data set into a graph would, for example, yield such a diagram showing the hourly rate by month for example, a project. And I can put in additional lines and so on. And I even can add styles. So there's a style which is XKCD style, and you can very easily create a graph that looks like this. And you don't have to fiddle around with string sizes and stuff. So just put in the data, select the style you like to have, and then you will get a graph like this. But there's lots of more cool things in R and around R. The first, and in my opinion most important thing, is the package repository. As you all know, Typo 3, you know how powerful an extension system and an official package repository is. So R does have the same, and there are at the moment about 8,000 official packages which you can download and add to your R installation, which each offers you additional options and possibilities to work with your numbers. And of course, as with Typo 3, the quality depends on what you're getting and what you're needing. Additionally, R is quite fast, so operations you do on the data are mostly a lot faster than you expect them to be, and you can process huge amounts of data. In the basic installation with no additional packages that allow for the maximum size, you can already work with 2 exponent 31 rows and columns at the same time of data, which is really huge. And if that's not enough for you, you can install a big size data package which only limits you by the amount of storage you have. So there's actually only physical limits. And of course, everything is open source. And I think in a Type 3 conference, I don't have to explain the advantages of this to you. So comparing Excel to R is a bit like having handy-manny compared to a real chainsaw. But this is only the beginning. Installing R is the one first step of having a tool that can do something with your data. But then you only have like a virtual object in your memory which was transferred from some raw data into something. But what you want to do is you want to get this data somehow and you want to transform it and then output it somehow. And that's why I've added a section with let's add more tools to it to show you what is possible with this R in the core and what can you do all around it. At first, there's something called RStudio, which makes working with R a lot more beautiful. I already showed you the command line stuff to frustrate you a bit, but of course there's a very good IDE for working with R, which is called RStudio. And if you now start RStudio, this is something like starting up R in the real world. It gives you a syntax highlighting editor which allows direct code execution in the editor, so there's no long waiting times, just start writing and let's go. They're excellent debugging tools, so you know the state of every variable and your memory and everything all the time. There's a console, of course, and there's a file browser and package manager and graph viewer and everything you need to work with your data very comfortably. Of course, RStudio is also an open source tool, so I really recommend if you want to give R a try, directly start with downloading R and RStudio, so you won't have these big hurdles of getting started. Then the next very interesting thing is OpenCPU, which is kind of a service which allows to run an R package on a server. And if you look up what does the web page of OpenCPU say what it is, it says the OpenCPU server provides a reliable and interoperable HTTP API for data analysis based on R. Whoa. What does that mean? Basically, it just means it gives you a very good API for everything you do in R, so you can access it from other applications. And that's really beautiful, because if you've written an analysis tool in R and want to give this data over to your website or to your company, accounting software or whatever, then it's very easy to do that with OpenCPU. And even in a simple web page, you can use the OpenCPU JavaScript library. In this case, there's a very simple call, which is called OCPU call. Then you just put in the name of the function you want to call in R. In this case, my example says it's called get overtime. So I want to know how much overtime a particular employee in my company did. Then I pass a username, and I will replace the ID in the HTML, which is called output, with the result from R. And that's it. So that was everything I needed to do to have R results in my HTML. Additionally, this allows me to keep R and everything which is a bit more developer related away from my employees, but still offer them the power of the tool. So what my employees see is just an HTML page. In this example, our target performance report. So a user which is allowed to see this report can just put in the needed data, like the report period, and then add their user credentials, press the generate report button, and then they will get the report which was defined in R and by our developers. So there's no software license required for the user, they just need a browser. And if they don't even have a browser, of course, OpenCPU or the server running it would be able to send an email like, once in a month, what are the numbers to your employees? Additionally, it's cool to work with LaTeX. And I'm not talking about the stuff you think about now. I'm talking about LaTeX, which is for the people did a thesis at the university, perhaps known as a document preparation system, which is widely used at universities. And it allows you to create beautiful documents, especially as PDFs, by just writing a text document. And I will give you a very short introduction of how this works and why this is so interesting. So you start writing a LaTeX document, then you put this into LaTeX, and you will get out a PDF. Looking into the code, this would mean you have something which says what document will it be, like a report or something. Then you have a begin and end document section, which is like in HTML, and then you have the content. If you now run this through LaTeX, you will have something which looks pretty much like this. Then adding a bit more structure would mean let's have a header, which is called chapter in this case, and it will look like something like this. The string chapter 1 was automatically added because that is defined in the document style, and if you want to look it a bit more like your company, you just choose something like, in this case, our DKD technical documentation style, and it will look like this. Or you choose another style and it will look like this. So this makes it very easy to create a beautifully looking report from the raw data. And LaTeX also seamlessly integrates with R. So you're able to place R variables directly in the LaTeX code. So there's no need to learn new template languages or anything. Just put them in there. And you can even put in R control structures, R code directly to execute it in the code, and you have it directly in your document. The next tool, which is really interesting in this setup, is a software called Freeboard, which is a company dashboard. And if you've maybe heard about Gecko board, you can visualize numbers or data on this dashboard. The advantage of Freeboard is it's open source, and you can get it as a hosted service. If you don't want that, you can install it on your own machine and run it on your own servers, so there's no important data going outside. It can use JSON interfaces really easy, so you can integrate lots of data sources and present the data directly on your screen. So, what's the big picture in this? If I draw it all on one screen, it would mean I have R in the center. Then I also have RStudio for working with our data. I can use loads of data sources, and the ones I've mentioned here, like JSON, Excel, XML, and so on, they're all supported by the beginning, like basic installation of R. So there's no additional packages required. And if you need more or different sources, just look for the specific package. Then the target format, pretty much the same. And using LaTeX, as explained, you can also do very nice PDF documents. If we then add OpenCPU at the top, we have also a REST API, which allows us to even add other tools like the mentioned Freeboard and so on. So, I promised you some real-world examples of what we already did with this kind of setup, and here it is. At first, I want to show you something I call a client report. Now and then, I want to know how well does one of our clients work for us, or is it good? Do we earn money? How are the numbers looking? So I've called this client report, and it's for our client Sauron. And the report looks exactly as our report, only the numbers are replaced with our fictional client Sauron. So looking into an overview, which would mean all the money pieces are given in gold pieces, so don't worry. The total revenue for this client would be 663,000, and we did 4 projects for this client in the selected time period, like first half of 2016. It we have a recorded time of 6,000 hours, average hourly rate of 103 gold pieces per hour, which is okay, and an agreed hourly rate, like the rate we decided with this client, of 110 gold pieces. Going into more detail, this would show me how much revenue did I do each month, with an average and a total, and at the bottom I've created a little graph showing the revenue for each month, so I see, is it going well, is it going upwards, downwards, or whatever. Then I find an hours report showing me how many hours did I work with this client, and a split up of how many hours we charged on a flat charge project, how many hours were free of charge for whatever reason, and how many hours were based on a time and material basis. On the last page, I've got a project sum up, which projects that we work for this clients on, and I see, okay, on reclaiming the One Ring was the biggest project for this client, so there were quite some hours into this project. The next thing I want to show you is a special timesheet, which was triggered by a real problem we had since we did a EU project in the last 3 years. And the requirement was that every employee have a timesheet each month which only states the time records of this project, and this had to be printed out and signed by every of our employees, which we didn't do before, because we didn't want every of our employees having like a signing session every month for every project, signing hundreds of sheets. And so we had the challenge of creating this, and R was a very good helper here as well. It was very easy to collect the data from our time recording software, print it out on a PDF, and have it on here, which said, this is the timesheet for the employee, whoever it is, in which project it was worked, what's the period, and what did the employee do. Then on the bottom, he had to sign it, and we could carry one big package of papers after the project to the reviewer, who checked everything and said, okay, that's perfect. A third thing I want to show you, and this might be something which is very interesting for you if you work like we do. We charge the time we work for, which is uncharged services, meaning there are loads of hours in our system, and every month I need to check which hours we worked, but we didn't charge our client yet. So what I do is I generate a report which states which client is the project for. In this case, the client would be DKD, of course. And then I would get a report which says I have in total 1,600 hours which have not been charged yet, and I get a list of clients and projects for these clients I have to charge or I have to take a look into, and having this report, I would see that for our client in Middle-earth, the project Reclaim the One Ring has loads of hours which are uncharged, so I need to speak to the project manager, which is stated here as well. So I go to my phone, call the Nazgul, and ask them, why didn't you charge the time to the client? Also, which is a nice feature of PDFs, you can link from PDFs, so the project number, which is a little bit green in the left, is clickable and directly takes you into our software for project management and allows us to see what's the details here, why wasn't it charged, are there additional notes, and so on. So, summing it up. What should you take home from this talk? Depending a bit on what's your role in your business. If you're a developer, I think the most important message would be that R is a really versatile tool for working with data, and meaning all kinds of data. If you're a developer or project manager, I think the message of that R very easily connects between different tools and allows you to take and give data from one point to another. And if you are a decision maker, I think the most important message would be that we are so satisfied with R and what R helps us to do that we already started offering development around R as services in our company. So I really recommend you taking a look into R and what it can do to you or your data in your company to help you. And this takes me to one of the last slides, asking you if you're going to drink a beer with me or if you want to ask me one or more questions.
Questions or beer? Question.
Yeah, thank you, Søren, for a nice talk. I would like to ask if you did some comparison between the other languages which can be used for the data analysis, like F# or Python, etc. And why did you choose R as the language of your choice?
We didn't do like a very detailed comparison, like doing all the charts and pros and cons. It's just that we had this situation where we needed a tool to work with data, and like the first thing that came to mind was that R was an open source tool, and we love to work with open source software, and so we decided to go a very simple approach of let's try to throw our problem into R and see if it is solved easily, and it was, and so we didn't go around and evaluate other tools.
Yeah, great, thank you.
Where do you collect the hour data from? Do you have an open source suggestion for this tool also? Because it's always a pain point with small agencies.
It's a pain for us too. We've written our own agency software which collects the data and which is connected to our issue tracking software, which is Redmine. So our employees can log their data into our tool and in Redmine, and it's all stored in our tool, and our tool offers a REST API, so I just connect to the REST API with R, get the data, crunch it, whatever, and then I can show it or do whatever I like to. So no recommendation for a wonderful tool, but if you have one, I'd like to hear.
Anybody else? No. Well then,
I've brought one. The one question, can you turn lead into gold? Of course. And the answer is yes, you can. By now it is possible to use a particle accelerator or nuclear reactor to turn lead into gold, but it's not very efficient, let me say. So if you have too much money, then spend it to turn lead into gold. Thank you for listening.
thank you. Don't forget the cards.